Okay, we are still solving systems of equations. This time we're going to be using a method called substitution. So if you'll remember just the concept of what it means to substitute something. So if x equals, let's say 3, and if I wanted to evaluate 4x plus 2, substitution says I know what x equals and I can substitute it into an expression, and then from there I can actually do some math, do some substitute, do some do some multiplication, do some simplifying, do some distribution, right? So substitution says I know what something equals. In this case, x equals 3, and I can substitute into an equation or an expression, and I can simplify or I can solve. All right, so that's the idea behind substitution. Is we're simply going to know what something equals, and we'll substitute. Okay, so here's a couple of steps though. You probably want to pause the video, write these down, and we'll go through these steps as we work through some examples. But just for reference, so here's what has to happen first. All right, so I've got to know what one variable already equals. Now remember, we're dealing with x's and y's. We just got through graphing some equations, and so x's and y's is what we're dealing with. So if necessary, solve at least one equation for one variable. In other words, I need to have either x equals something or y equals something, right? I've got to know what one of those variables equals, because that's what I'm going to substitute into the next equation. Okay, so if I have to do step one, that's what I'm trying to do. I'm trying to get x or y by themselves. Okay, then I'm going to take that result, x equals or y equals, and I'm going to substitute into the other equation. Okay, that's where substitution comes from. We're going to substitute x equals or y equals into the other equation, and then we're going to solve the equation. Now, since we're looking for a solution, and the solution to a linear equation is a linear pair or pairs, then I'm looking for an x and a y. So whichever one step 2 gives me, step 3 says that I've got to take that value, either x equals something or y equals something, and then I've got to solve for the other variable. And the final step, I need to write it as an ordered pair. So once I know what x equals and y equals, that's an ordered pair. All right, so here's our first example. Use substitution to solve the system of equations. Now, one of the things that we'll get used to as we go through more of these types of problems is the different forms of an equation. So this particular system, two equations, y equals 2x plus 1. We recognize this as slope-intercept form, and if I wanted to graph this, I could. 3x plus y equals -9 is not slope-intercept. So if I was going to graph it, I would have to kind of algebraically manipulate this equation to get y by itself. That's not what we're doing this time, but just so you're comfortable seeing the different forms of linear equations as we go through. So step 1 of the process was I need to know what y equals or x equals before I get started. And in this case, I already know that y equals 2x plus 1. Now I don't know what x is, and I don't know an actual value for y yet, but I do know that y equals 2x plus 1. And so I can take 2x plus 1 and substitute into that second equation. And here's what you're going to see. So 3x plus, and I'm going to put some brackets here for y. 3x plus y equals -9. And now we're going to substitute. Well, y equals 2x plus 1. So I've substituted in. Now, if I look at this, I should notice that I only have x's. Right? So this is just an equation. This is just an equation that we can solve by simplifying and potentially using distribution. This is something we can solve. Okay, I'm going to use way too many steps here, just for a couple of examples, just to give you a chance to kind of feel your way through this. The parentheses aren't really doing anything for me, so we get to just kind of evaluate. They go away. 3x and 2x, 5x plus 1, subtracting 1 from both sides because I'm solving for the variable that I have. I have an x. Divide both sides by 5, x equals -2. And now I know what x equals. But remember, the solution to a linear system is an ordered pair, right? So now I need to know what y equals. So let's go all the way back up here to this original equation that had y equals. And it told me that y equaled 2x plus 1. Except now I know that x equals -2. So we'll substitute again and we'll evaluate. Okay? So 2 times -2, -4, plus 1 is -3. And that's what y equals. Y equals -3. Now I have an ordered pair. X is -2, y is -3. And that's what my final answer should look like, an ordered pair. Okay? Now, down here in the bottom right, notice that it says I could check by plugging in, or I could check by graphing. In other words, I have two equations up here that have x and y in them. If this is a solution, this x and y should make both of these equations true if I substitute and evaluate. The other thing that we could do, and we won't do this often, but you could do, is you could check by graphing. You could take these two equations and put them on coordinate plane, and that should be the point that they overlap. That should be the point that they touch. Okay, this next one is yours. Okay, use substitution to solve this system. So we already know what y equals. Y equals 3x plus 10. So we'll substitute in. So there's 2x plus. Now this one is 5 times y. So that gets a little more interesting. I gave this to you on purpose. So y equals 3x plus 10. So there we go. We only have the variable x in this expression. So we simplify. We solve for x. Okay. Distribute the 5. The x's go together. 50 moves to the other side. Divide both sides by 17. And x equals -3. Take that x all the way back up here to the top. And 3 times x, which is -3, plus 10. This is going to give us our y value of 1. So x is -3, y equals 1. And that is our ordered pair. And again, we could plug it back in, we could graph it, and this would be the solution that we should get. Now, sometimes we do have to do step 1. In other words, I'm looking at this system of equations and I don't know what x equals yet. I don't know what y equals yet. And so I have to decide in this system which is the easiest variable to get by itself. And I hope what you see here is that x is already has a coefficient of 1 in front of it, which means to get it by itself, I simply have to subtract 2y from both sides of the equation. And now x is by itself, and I know that x equals -2y plus 6. And so now that I know what x is, I substitute. Okay, 3 times x minus 4y equals 28. So I put my x in. X is -2y plus 6. Okay, this equation only has y in it, so I can distribute. Okay, and now I can solve. Right, I can get the y by itself, add them together, subtract the 18, and y equals -1, which is part of my solution. I take that y all the way back up to one of these other equations and substitute it in. And so we've got -2 times y And so we find out that x equals 8. And so that's our ordered pair, 8, -1. Okay. And again, this one we actually had to take that first step of getting x or y by itself, whichever one is easier. Solve for the variable that we can, and then plug that value back in to find the other one. All right, let me give you one more to do. And again, you figure out which variable you want to get by itself and then solve using substitution. I hope you saw the y was easiest to get by itself in this bottom equation by adding 3x to both sides. And so now we know that y equals 3x minus 13. And so we'll plug in 3x plus minus 13 for y. And we'll solve, okay? And I'm not going to go through all the steps here, but we should get down here to x equals 4, and then plug in 4 back in. We should get y equals -1, and so that would be my solution. Okay. All right. Now, one of the things I want to mention here before I go, remember that there are two special cases, right? Everything we've worked today, we've come up with a solution, okay? And if you remember, that means that those systems have been consistent and independent, okay? Consistent, independent. Remember, that meant one solution. But there are cases where we have no solution and we have an infinite solution. And so those will be the special cases that we'll be looking for as we kind of hint and work through some other problems. What's going to happen is, in the solving of the system, all of the variables are going to disappear and you're going to be left with a statement. It's going to be 4 equals 4, right? That's a true statement, so we would be looking at infinite solutions. Or you're going to get 2 equals 7, which is not true, and that's going to be our no solution. So we'll still be looking for special cases. We just have to make sure we see them when we get there. All right.